Graphing quadratic functions, we now have all the tools we need to make a good graph of a quadratic function by identifying the key points of any quadratic. The first key point is the y-intercept, which we know we can find when x equals 0. That's pretty simple. We just have to simplify the function. The next two is that there are up to 2 x-intercepts when we make f of x or y the entire quadratic equal to 0. And sometimes when we do this, there'll be 2 solutions, sometimes there'll be 1 solution, and sometimes there'll be no real solutions, and then there'd be no x-intercepts. The vertex, we've talked about getting an expression into vertex form, so we could identify the vertex h comma k. And then one more is the direction of the quadratic graph. Remember, a quadratic graph either opens up or opens down. If the a term, the thing in front of x squared, if that is positive, the graph will open up and look like a happy face smile. But if the a term is negative, it will be a sad negative face smile. Well, not a smile, a negative frown. And it will open downward. So we put this information together to come up with the graph of any function. So for example, if f of x is 2 times x minus 1 squared minus 8, we just have to identify these 4 pieces of information in order to know for sure what is the graph of the function. So first, the y-intercept. We find the y-intercept by making the x equal to 0. So that's going to be 2 times 0 minus 1, which is just negative 1, squared minus 8. Well, negative 1 squared is 1 times 2 is 2 minus 8. And so 2 minus 8 is negative 6. So the y-intercept on the y-axis is at negative 6. We'll plot that on the graph here. The direction, let's do the direction next. We'll come to the x-intercept last because that's probably the one that takes the most work. The direction, we look at the a for the direction. The direction is positive, so it is a happy face parabola. It's going to open upward. The vertex. The vertex is at h comma k, and remember it's the opposite of h, so that's 1 comma negative 8. So we can put that on our graph, 1 comma negative 8 down here with the purple dot. That is our vertex. And then the only thing left is the x-intercepts. To find the x-intercepts, we make everything equal to 0. So we have 2 times x minus 1 squared minus 8. If I add 8 to both sides, we get 8 equals 2 times x minus 1 squared. Divide both sides by 2, and I get 4 equals x minus 1 squared. Take the square root of both sides, and remember when we take the square root, we need that plus or minus. So the square root of 4 is 2, so it's either 2 equals or negative 2 equals that x minus 1. If I add 1 to both sides, x could equal 3. Or if I add 1 to both sides, x could equal negative 1. So we have 2 x-intercepts. One of them's at 3, and one of them's at negative 1. And now all we have to do is connect the dots to make our graph. Let's see if I can do that here. Something like that will be our parabola. This is the graph of 2 times x minus 1 squared minus 8. This one was nice because it was already in vertex form. Sometimes, though, we cannot simply graph a parabola. We need to first put it into vertex form. And we know how to do that by using that completing the square method. First, we factor out the a out of the first 2 terms. So we have negative 2 times x squared plus, minus actually, minus 3 halves x, and then a plus 1 at the end. Finding that magic number, let's just do it underneath. Negative 3 halves times 1 half. And squared, that's negative 3/4. And negative 3 squared is 9, and 4 squared is 16. So we have 9/16. That 9/16 needs to be added inside the parentheses and also subtracted outside the parentheses. We'll use the space up here. But when we do, we have to multiply it by the negative 2 out front. So it's actually going to be adding, and then the 2 over 16 reduces to 8. So we've got plus 9/8 there. So let's see what we have. We have a negative 2 times. So when we factor this, it's x minus 3/4 squared plus 1 is equal to 8 over 8. So 8 plus 9 is 17/8. And now we are in vertex form. So we can jump ahead at this point and say it's really easy to see that the vertex is at the point h comma k. We take the opposite of h, which is 3/4, and k is 17/18. I'm sorry, 17/8. Which as a decimal would be, to make it easier to graph, 0.75 comma 2.125. So graphing that at 0.75, 2.125, right about there is going to be our vertex. Another easy point to find is going to be the y-intercept. To find the y-intercept is actually going to be easier to go back to the original equation and make all the x's equal to 0, because we have negative 2 times 0 squared plus 3 times 0 plus 1, and that's nice because most of that stuff goes to 0, and all we're left with is y equals 1. So we have the y-intercept at 1. We should also be able to, at this point, tell us what the direction is. Because that a is negative in both vertex form and standard form, we have a negative parabola, a sad face, so it's going to be facing down, which we can kind of see if you look at what's going on with the vertex and the y-intercept. It has to go down to the y-intercept. So that's believable. So all we are missing at this point are the x-intercepts. And we could go either way for the x-intercept. I'm going to go to the original equation again for the x-intercept, because with negative 2x squared plus 3x plus 1 equals 0, we can use the quadratic formula where a equals negative 2, b equals 3, and c equals 1. So x is equal to the opposite of b, plus or minus the square root of b squared, minus 4 times a times c all over 2a. So plugging those values in, and then we're going to use our calculator to help us simplify inside the square root. So we have negative 3 plus or minus the square root of 9 plus 8 is 17 over negative 4. And then we've basically got, well, let's see, what's the square root of 17? It's a little bit more than 4. Let's call it 4.1. So we've got negative 3 plus 4.1 and negative 3 minus 4.1. So when we do the plus, negative 3 plus 4.1 is positive 1.1 over negative 4, which is going to be a negative 0.275. So our first x-intercept is at negative 0.275. Our second one is when we subtract negative 3 minus 4.1 is negative 7.1 divided by negative 4. And when we put that in the calculator, we get 1.775. And so now all we have to do is connect the dots to get this shape of a parabola. So nothing really new. We're just putting pieces together that we've seen before. We can take a quadratic and put it in vertex form. We can find the vertex. We can find the y-intercept. We can find the x-intercepts. We might need a calculator, we might need the quadratic formula, we might be able to factor, but we can put these pieces together to come up with the graph of a parabola or a quadratic function. Take a look at the homework, give it a good go, and let your instructor know if you have any questions.